solve dy by dx minus y into tan x, which is equal to sin x cos square x divided by y square. Observe carefully, the differential equation, the given differential equation is of the form dy by dx plus p of x into y, which is equal to q of x into y power n. Here p of x is some minus tan x and q of x is this is sin x into cos square x, and y power n is, if we take this y square to the numerator, that becomes y power minus 2, that is our y power n. So clearly this is an Bernoulli's form equation. We have to reduce this form to a linear differential equation. For that, take this y square to the left hand side. We get as y square into dy by dx minus tan x into here y square into y is y cube, which is equal to sin x into cos square x. Call this equation as equation number 1. Now observe carefully, this is an equation of the form x and y. We have to reduce this to an equation containing u. For that, take u is equal to y cube. Here this y cube as u, if we take the y cube as u and differentiate this term with respect to x, we get as du by dx value is, differentiation of y cube is 3y square into, again differentiating y with respect to x, that is dy by dx. Next step, take this 3 to the left hand side, we get as y square into dy by dx, this value becomes 1 by 3 into du by dx. Now substituting this value as 1 by 3 into du by dx and y cube value as u, we get as 1 by 3 into du by dx plus, here take minus tan x as this into, here y cube is u, which is equal to sin x into cos square x as it is. Next step, take LCM as 3 and simplify, we get as du by dx plus, here taking LCM means you have to multiply by 3, that is minus 3 into tan x into u, which is equal to 3 into sin x into cos square x. Now we can conclude that the given differential equation of the form du by dx plus some p dash of x into u, which is equal to q dash of x, where p dash of x and q dash of x are some values containing x. Therefore, this is a linear differential equation form. So we have to find the p dash and q dash value. Here p dash is minus 3 tan x, q dash is 3 into sin x into cos square x. Once we obtain p dash x and q dash of x value, we have to find the integrating factor value, that is integrating factor is exponential power of integral of p dx. Substitute p value and simplify the integration. Exponential power of integral of p is minus 3 tan x into dx. Minus 3 is constant, take as it is, into integration of tan x is log of secant x. Therefore we get as exponential power of minus 3 into log of secant x. If we take this minus 3 inside the bracket, this is of the form n log m. So this is of the form log n power m. Hence we get log of secant power minus 3x. So exponential and log gets cancelled. If we take this secant power minus 3x to the denominator, that becomes 1 by secant cube x. We know that reciprocal of cos is secant. Therefore, in the place of 1 by secant cube x, we can substitute as cos cube x. This is our integrating factor value. Once you obtain the integrating factor, we know that the solution for a given differential equation is of the form u into exponential power of integral of p dx, which is equal to integral of q into exponential power of integral of p dx into dx plus c. Next step, substitute q value and integrating factor value, we get as u into, here integrating factor value is cos cube x, which is equal to integral of q value is 3 sin x into cos square x into integrating factor is cos cube x dx plus c. Multiply cos cube x and cos square x, we get as integral of 3 sin x into cos square x into cos cube x is cos power 5x dx plus c. Next step, to integrate this value, take cos x as t. Here if we substitute cos x as t means, if we differentiate this value with respect to x, we get as dt, which is equal to minus sin x dx. Substitute in the place of sin x dx as dt and simplify, we get as u into, here in the place of cos x we have to substitute as t, therefore we get ut cube, which is equal to integral of, here 3 as it is, sin x into dx is minus dt, therefore we get minus 3 into, here cos x is t, hence we get t power 5 into dt plus c. Understand carefully, here 3 into sin x cos power 5x dx. To simplify the integration, substitute t as cos x, therefore differentiating this value becomes dt, which is equal to differentiation of cos x is minus sin x dx. So in the place of sin x dx we can substitute as minus dt, and in the place of cos x substitute as t, we get as u into t cube, which is equal to integral of minus 3 into t power 5 into dt plus c. Now we can integrate easily. Minus 3 is constant, take as it is, into integration of t power 5 is t power 6 by 6. That is u into t cube, which is equal to minus 3 is constant as it is, t power 5 integration is t power 6 by 6. Here 3 ones are 3 twos are. Substituting t values cos x, we get as, also u value is y cube into t is cos x, therefore we get cos cube x, which is equal to here minus t is cos x, therefore we get minus cos power 6x divided by 2 plus c. This is a solution for a given differential equation. This is a procedure to find the reducible to linear differential equation.